Hey everybody. So now we're going to talk about geometry section 8.3 notes. You can follow along in your textbook. Like I said, most of these examples that we do here are also in the textbook. The good news about this section is that nothing is totally new. Okay, we're still using our trig functions. We're still using sine, cosine, and tangent. If you look at the very first example I have up here, if I want to figure out the length of, let's say, side KL using trig, we would normally say sine, cosine, or tangent of the given angle. But if you look, you only have a right angle, you have a missing angle, and you have another missing angle. So that presents a problem. And that problem can be solved by using what are called inverse trig functions. And inverse trig functions, you can think of it kind of as just like division is the opposite of multiplication. It undoes multiplication. Subtraction undoes addition. Well, inverse trig functions undo normal trig functions. You're going to use the same exact ratios. So I'm going to write up at the top here again, SOHCAHTOA, so we don't forget. And what's going to happen now is we're going to be looking for, like I said earlier, a missing angle. We'll be given a right triangle, we'll be given two sides, and we're going to be looking for the missing angle. And the way these inverse trig functions look, you have your hypothesis and your conclusion. So the hypothesis says if sine of x degrees, so if sine of an angle is a over b, and I'm getting a over b from this particular triangle. Uh-oh, I'm missing my letter R again. Whoop, there it is. So in this case, it's saying if the sine of x is a over b, so in other words, the sine of x is opposite over hypotenuse. Here's my x. We have opposite over hypotenuse. Then x, the degree isolated, is going to be the inverse sine of a over b. So if I'm looking for an angle, I'm going to take what is called the inverse sine. Sine to the -1 power, okay? If cosine of x is c over b, and again, I'm over here, I'm dealing with x, cosine is adjacent over hypotenuse, so c over b. If cosine of x is c over b, then if I want to isolate x, if I want to get, let me write adjacent over hypotenuse there. If I want to get x by itself, I'll take the inverse cosine of this function, or of this ratio, and that'll get x by itself. And the last one, if tangent of x is a over c, and remember, tangent is opposite over adjacent. So if I come over here again, I have x, I have opposite over adjacent, a over c. If I want to get x by itself, then I'll just take the inverse tangent, tangent to the -1 of a over c. Okay, so these questions say use your calculator to find the value of each angle measure to the nearest hundredth. So, whoops, sorry about that. Again, my phone is really shaky, so I'm doing it myself, so it makes it kind of interesting. Okay, so I have cosine of x equals 4 over 5. We don't even need a picture for this. So in order to get x by itself, I'm going to take the inverse cosine of 4 over 5. Okay, and the way I do this in my calculator is, first turn my calculator on, you'll notice you have your sine, your cosine, and your tangent on your calculator, and right above them, you have inverse sine, inverse cosine, and inverse tangent. In order to get that light blue, you guys already know, you hit the second button, and then you hit sine for inverse sine, second cosine for inverse cosine, second tangent for inverse tangent, and again, I'm in degrees. Super important there. So if I want to find x, I would take inverse cosine of 4 over 5. Please include those parentheses. So second cosine, there's inverse cosine, and then 4 over 5. Close my parentheses, and then enter. 36.87. So that would be my answer. Degrees. Make sure you put your little degree unit there. That's super important. Okay, if I want to do the same thing, let's just jump down to number 3. Tangent of x equals 8 over 5. I want to figure out the value of the angle. So I will just take inverse tangent of 8/5. And if I was going to homework quiz you on this, I would want to see this. I want to see what you're doing to get your answer. So in my calculator, I'd clear it. Inverse tangent of 8/5. Close my parentheses and then hit enter. And you get 57.994. You could either make it 0.995 or just make it 58 because 9 bumps this 9 up, which bumps this 7 up to an 8. So 58 degrees. You would do the exact same thing with sine of y and sine of y here. Okay? Now, in these problems, you want to find the unknown angle measure and then round your answer to the nearest hundredth. 2 places. That's very important. If I say to round it 2 places, you better round it 2 places. So, again, we have a right triangle. We have 2 missing angles, but in particular, I need this angle here. So this is going to be my reference angle. This is what I'm going to circle. Then I'm going to label my sides with this as my reference angle. So I have 12, which is straight across, so that's opposite. And then I have 17. It looks like it could be adjacent, but notice it's not a leg. It's straight across from my 90-degree angle, so it's my hypotenuse. Thinking about my SOHCAHTOA again, which one of these, sine, cosine, or tangent, uses opposite and hypotenuse? That's sine. Sine is opposite over hypotenuse. So I'd come down here. I'm going to write my function, my whole thing out, and I would look for this on a test or a quiz. Sine of x is equal to opposite over hypotenuse, 12/17. And then x, you'll notice x is an angle, which is important to pay attention to. So now in order to figure out x, I need to get rid of this sine. The only way I can get rid of sine function is to take inverse sine of both sides. So I don't need to show it on this side. I can just get x by itself is equal to, and then you would type, or you would write out inverse sine of 12/17. When you plug that into your calculator, clear this out, inverse sine of, what was it, 12/17? Yep. Close my parentheses, enter. 44.90. And again, put your degree symbol up there, and it says 2 places, so you have to include that 0. Let's do one more. In this case, right triangle, 2 angles missing. In particular, we're looking for x. So I'm going to circle that. That's my reference angle. Label my sides. Straight across from x is 15. That's opposite. That is one of my sides that's given. Notice I'm just not paying any attention to the side that is not given. Okay, just like before in the last section, that's exactly how we did it. So JL has no number with it or variable, so forget about it. Who cares? We don't need to worry about it. We just want to worry about the ones that are actually given values. So I have opposite, and then if I'm standing at x, and I look to the side, I bump right into my adjacent. Again, this is not the hypotenuse because it's not across from 90. So since I have opposite and adjacent, going back up here, opposite and adjacent is tangent. So I'm going to use my tangent function. So tangent of x is equal to 15, opposite over adjacent, 18. In order to get x by itself, I have to take inverse tangent. And when I plug that into my calculator, I'm not going to show you guys that. You should already know. 39.81 degrees. Whoop. Rounded 2 places with my degrees. Alrighty. There's a few more examples on the next page, including coordinate geometry. I'm not going to worry about all of these. You can look in your book, and I'm also attaching some Khan Academy videos, I believe. Yes, I'm also going to attach some Khan Academy videos. So hopefully that's a little bit helpful, and that is finding the value of a missing angle using trig. All right, guys, hope you're doing great. I will talk to you soon. Bye.